it was known from previously that there are only 2% of that part are coding genes. And it was a little bit disappointment because the human Homo sapiens has only about 20,000 coding genes, but when there is about 100,000 different types of proteins in the cells. So the secret is in the regulation of the gene expression. And in that time, the vast majority of human genome was considered like a junk DNA, but now, since the regulatory role of the remaining of genome has been discovered, it is now considered as like dark matter of the genome. But it's interesting that 80% of the transcriptome belongs to the non-coding RNAs, so those RNAs which are not coding for the proteins. Here you can see there are, in essence, two types of non-coding RNAs, so-called housekeeping RNA, non-coding RNAs like ribosomal or transport RNAs, which are involved in regulation of protein translation. And also there are much more regulatory non-coding RNAs, which are artificially divided by size to those which are less than 200 nucleotides and longer than 200 nucleotides. Here you can see that they have many different, on one side, sizes, but also different type of regulations. But in my talk, we will concentrate on two types of non-coding RNAs, so-called microRNAs, so small non-coding RNAs, and also long non-coding RNAs. There is also one rising star on the sky of the non-coding RNAs. So those are circular RNA, and since there's also lots of already published material on the role of circulating, not circulating, but circular RNAs in gynecological cancers, I also call members of the Gynocare Action to write a review paper, because microRNAs and long non-coding RNAs has been recognized as important in the rare gynecological cancers. So members of the Gynocare Action has already published four review papers. I wanted you all to read them. Today I will not talk about the material which is directly related to rare gynecological cancers. I will rather present like a standard experimental procedures which are used in studying the role of non-coding RNAs in cancers. So as an introduction, a little bit more on the microRNAs. So those are small RNAs, about 22 nucleotides long. They are transcribed from microRNA genes. There are about 1,000 microRNA genes in humans, which codes for about almost 2,000 mature microRNAs. I will not talk about the biogenesis. It's quite complicated. It would take too much time, but what is important for you to remember that those microRNAs regulate post-transcriptional gene regulation by binding to mostly to prime untranslated region, and by that they either tag that mRNA for the degradation, or they cause a translation repression. What is also important to remember that they are promiscuous, what means that one microRNA can regulate multiple mRNAs and also opposite. And it is considered that almost 60% of human genes may be regulated by microRNAs. So in general, it is considered that if certain microRNA is overexpressed in certain type of cancer, then also that its target gene should be downregulated. So long non-coding RNAs are much complicated because there are many different transcripts. So you can see that there's almost equal number of genes, long non-coding RNA genes as protein coding genes, but there's also lots of different types of transcripts. So everything is again about regulation, alternative splicing and things like that. And their biogenesis, it's much similar to the mRNAs, except that they are not eventually translated. And they are classified mostly based on the location in respect to the protein coding genes. And here you can see there are mechanisms of action, but I will not talk about that, except the one you can see here. So they can act like a decoys in a system which is called competing endogenous RNA. So in essence, long non-coding RNAs compete with messenger RNAs for binding of microRNAs. So they are called like microRNA sponges. And in that way, they affect expression of the target gene. So in essence, if there is an increased quantity of long non-coding RNAs, they bind microRNAs to themselves, and in that case, microRNA target genes is normally expressed. So often, when you read literature nowadays, you will see that they try to connect certain long non-coding RNA with microRNA and at the end with the mRNA in so-called axis. And also they are creating competing endogenous RNA networks. So now I will talk a little bit about these standard experimental procedures, how to study that interaction of this axis and its connection with the pathology of a certain type of cancer. So it's obvious that when you start research, you decided which type of cancer you will study. So this is kind of a logic, but what is important, and we have heard that about during those 3 days, that it's very important to select control tissue. Because, for instance, healthy ovaries or even joining healthy tissue is very often used as a control tissue. What is in essence wrong, especially, for instance, if you study high-grade serous ovarian cancers, because it is known that they mostly arise from fallopian epithelia. So the next step is expression profiling. So you want to discover expression of as much microRNAs as you are interested in. So in essence, there are three steps, like a classic qPCR arrays and also now obsolete microarrays, because the problem with them that they are predefined. So today mostly is next generation sequencing for discovering expression unknown and also new either small or long RNAs. So after analysis of this large profiling, you got certain number of differentially expressed RNAs. So then the next step would be validation on the much larger number of samples. So it is done with the classic qPCR with cyber or probe chemistry. So long non-coding RNAs and mRNAs are in essence studied on the same way, but microRNAs, since they are much small, so the reverse transcription must be special, and also housekeeping genes are different. So in that step also, these expression levels are correlated with clinical pathological characteristics, and also it's tried to see if this expression could be used as a prognostic or predictive biomarkers. And what's interesting that those RNAs are also present in lots of body fluids. So now when liquid biopsies are very popular, so that they are easy to study and use as non-invasive biomarkers. But of course, you don't always need to start with the expression profiling. If you are interested in certain microRNA or long non-coding RNA, you can start directly with that. So as I showed you earlier, these competing endogenous RNAs are in essence, network of RNAs which compete for binding microRNAs. So microRNAs bind to specific part of, or they have distinctive motif of nucleotide with which they bind. So you can use that to predict to which genes or will certain microRNA bind, or to which all microRNAs can certain gene bind. So there are also lots of experimental and so database with experimentally verified interactions, but there are also lots of number of bioinformatics tools which are used for the target gene prediction. So the next step, especially if you study interaction which was not previously known, you must prove physical interaction between either microRNA or long non-coding RNA and microRNA of interest, and this is usually used with the reporter gene assay. I don't know how many have heard about that, but in essence you have a plasmid which has cloned luciferase gene. I suppose everyone knows about the fireflies or kriesnice in Croatian. So it has bioluminescent characteristic. So in essence, you clone your 3' UTR or part of the long non-coding I, which predicted binding site downstream of luciferase gene. You transfect your cell line of interest with that plasmid, and then you measure the luciferase activity. So if luciferase activity is decreased or increased, in that way you can conclude that there is interaction between microRNAs, because as I say, you have to co-transfect cells with that type of plasmid, and also with either microRNA inhibitors or mimics. And also it's important that you can see on the right side that you must make two different types of plasmid, one with a wild type sequence and one which has mutated. So in that case you can be sure that that particular sequence is targeted by microRNA. So the next step, and this is probably the most important one, is to see how this combination of long non-coding RNA, microRNA, and mRNA affect biology of a cancer cell. In essence, you must prove that this dysregulation of expression is the cause of that particular cancer. So we have heard also today that selection of cell lines is a very important step, because you must, of course, select cells that are models for your cancer of interest. So the problem is that lots of cell lines are either misclassified or even contaminated with other cells, and also it's often not so easy to determine what is the cell of origin or cancer of origin or particular cell line. So this Cellosaurus is very useful database, and also we had today previously there's also some genomic databases from which you can collect either transcriptomic or genomic data to have more insight on the cell line which you are interested in. And also people usually use wide number of cells, like the cell panels, and then decide in which one the expression of RNAs of interest mostly resemble the situation in the clinical samples. So there are very different and very large number of cell-based assays which are used to see if something, either treatment with a drug or with RNAs, affect biology of cell. So you can modulate either microRNA or long non-coding RNA expression with the different mimics and inhibitors. So those larger RNAs are modulated either by, if you want to overexpress, you use overexpression plasmids, or you can decrease or diminish expression of that gene with a small interfering RNAs. And here you can see that different characteristics of the cells, like proliferation, invasion, migration, colony formation, apoptosis, and cell line, are usually studied with many different types of assays. And also what is important that, for instance, if you see that certain microRNA is overexpressed, when you first inhibit its expression, and you see that this decrease pathogenicity or tumorigenicity of the cell, then you can also have to perform these so-called rescue assays to see that overexpression of this microRNA or gene will increase tumorigenicity of the. In that case, you can only be sure that these effects are directly related to this RNA. And down you can see different types of those assays. So this purple color, this assay, MTT assay, is used for measuring cell proliferation. To the right, you can see so-called wound healing. So you make a line with a pipette tip, and you measure repopulation of cancer cells. Also downstairs, you can see measuring apoptosis. This, again, purple is colony formation unit, and down right is how looks measuring the cell cycle. So now I will talk a little bit about our work. Although we are in that particular study, we were interested in high-grade serous ovarian cancer, but you will see later that we have quite a large experience in ovarian tumors. So Hedgehog-Glee signaling pattern, I don't know how many of you have heard about that, but this is the major research topic of our lab. So it's one of the signaling pathways which are mostly active during the embryogenesis, when it is involved in body patterning and organ development. In adult tissues, it is mostly inactive. It primarily serves for tissue homeostasis and wound healing. So it's kind of obvious that aberrantly activated signaling can lead to cancer development. And what's particular for it, it was discovered in Drosophila, and lots of genes got names according to the phenotype of fruit fly larvae. And so they discerned that mutations in one gene, which was afterwards named Sonic Hedgehog after the video game character, has some spikes. So that's the hedgehog signaling. I will not go too much into the detail about the signaling, how it works, but what's important to remember that the final activity or effect of the gene of the pathway are activation of transcription, which is led by the family of transcription factors GLI, and you can see also here that they activate transcription of many genes which participate in carcinogenesis. So they somehow consider that almost 1/3 of cancer-related deaths are somehow connected with this signaling pathway. So here you can see our experience with that signaling pathway in ovarian cancers. And in general, we try to find, is there any either genetic or epigenetic cause of aberrantly activity of that hedgehog signaling pathway. So at one moment, we wanted to see if there is any correlation between microRNA and expression of genes which belong to that pathway. And there's about 40 almost 50 genes involved in the transducing the signal through the signaling pathway. So we we use microarrays, and on the smaller number of samples, you can see here that we use 16 tissue samples of high-grade serous ovarian carcinoma and 8 samples of healthy fallopian tubes, and that we get quite a lot, especially differentially expressed mRNAs. So next was our intention to see what's the situation with those differentially expressed microRNAs and Hedgehog signaling pathway genes. So we got these results. What we can observe in essence that primarily differentially, so what can you observe that all genes which are differentially expressed are in essence decreased in the ovarian tissue samples. So on the opposite side, all those microRNAs are increased in ovarian cancer samples. So next, what is also important to validate those results on the bigger sample size, because we observe that certain microRNAs has lost their statistical significance. So next, we want to see, as all previously, are those genes known or putative targets of those microRNAs? We observe here that those microRNAs which target BCL2 genes, this interaction is known and experimentally proven, but those microRNAs which target Indian hedgehog gene and GLI3 gene are not, those interactions are not known. So next we observe what's the modulation of the expression of those microRNAs, what are the effect on the expression of their target genes. We observe on the mRNA level that their expression is decreased after overexpression of microRNA mimics, but unfortunately this is not so plausible on the protein level. And also what we want next to see if there is a physical interaction between those microRNAs and target genes. And as I said previously, we use luciferase assay to show that although the decrease of luciferase activity is statistically significantly decreased, but this decrease is not so strong. And also we wanted to see what's the role of this combination of mRNAs and microRNAs on the biology of ovarian cancer cells. So we performed different types before mentioned cell-based assays, and in general we observed that the largest impact on the biology of high-grade serous ovarian cancer cells showed interaction between GLI3 gene and microRNA 200B. And so as a result, we can conclude that healthy fallopian tubes and high-grade serous ovarian cancer show this distinctive transcriptome, either mRNA or microRNA, and then it could be concluded that hedgehog signaling is downregulated in high-grade serous ovarian carcinoma, and that downregulation could be caused by overexpression of microRNAs. In the meantime, we got also interested in long non-coding RNAs, because we have observed that downregulated microRNAs, downregulated long non-coding RNAs are also targets of those upregulated microRNAs. So this axis could be actually the cause of this downregulation. And also, what is also known from the literature, that activation of this signaling pathway is not a frequent event in ovarian cancers. So at the end, I would like to thank all my colleagues and collaborators, and thank you for your attention. And as a secretary of the Croatian Association for Cancer Research, I invited you to come to Zagreb this September. There are still some opportunities for short talks, because we are organizing biannual Congress every 2 years, and we are affiliated National Society to European Association for Cancer Research. Thank you.
Really, thank you, Petar. A very, very good lecture, especially explaining the signaling pathways. May I just ask you, so yes, you have the details, so it's in November 10 to 12. Yes, in fact, your colleague, Dr. Maya Sabol, did mention this, so congratulations on organizing this. And yes, thank you for extending the invitation to us as well. So any questions from the audience to Professor Petar? And I don't see any questions on Zoom. So I think it's been extremely clear. Thank you so much, and thank you for your presentation. And I think we can move on now to our next distinguished guest. So Professor Nelly Bashevska, Bashevska. So sorry about my pronunciation. So Professor is from the Department of Histopathology and Clinical Cytology at the University Clinic of Radiotherapy and Oncology, Faculty of Medicine, University of St. Cyril and Methodius in Skopje, of course, in Macedonia. And she has a very interesting lecture to give us on incidental gonadal germ cell tumors. So the floor is yours.
Dear colleagues, let me first thank the organizers, Professor Alejo and Professor Tofosky, for the invitation for this interesting training school about rare cancers, especially on this Go Day, because we are celebrating Gynecology Oncology Day today. I have no disclosures, and this is the outline of my presentation. I will start with case reports. Then we'll have a discussion about gonadal dysgenesis, especially about Swyer syndrome, and about gonadaloblastoma, its clinical and molecular and pathological characteristics, because it is the most frequent germ cell tumor diagnosed in these patients, finishing with some take-home messages. I'll start with case reports, and in the last 20 years, we had only 3 cases of patients with Swyer syndrome in which an incidental germ cell tumor was diagnosed in their gonads, one in 2006, the second one in 2008, and in 2012 was the third case. The patients were young, 17, 20, and 19 years old, and they had similar clinical history, presented with primary amenorrhea. They all have an ambiguous female phenotype, and their gonadotropins were high while estradiol was low, pointing to hypergonadotropic hypogonadism, while by cytogenetic analysis a no-mosaic 46XY karyotype was detected. Therefore, under the tentative clinical diagnosis of 46XY complete gonadal dysgenesis or Swyer syndrome, a prophylactic bilateral laparoscopy gonadectomy with bilateral salpingectomy was performed in cases 1 and 3, while bilateral laparoscopy gonadal biopsy followed by bilateral gonadectomy and salpingectomy, pelvic lymphadenectomy, as well as peritoneal and greater omentum biopsy was performed in case 2. It is very important that the uterus was preserved in all 3 cases. This table summarizes the gross appearance of the gonads in all 3 patients, and as you can appreciate, the right gonad was larger in all 3 cases, measuring 3 centimeters in case 1, 3 centimeters in case 2, and 4.5 centimeters in case 3, contrasting to the left gonad, which had an appearance of strict gonad with the largest dimension of approximately 2 centimeters. In case 1, the gonads were received bisected, and upon dissection, both gonadal streaks had similar variegated appearance with gritty consistency due to multiple areas of microcalcification. The gonads were completely sampled and embedded, and you can appreciate from this gross macroscopy figure the right gonad and fallopian tube and the left gonad and the fallopian tube. In case 2, we initially received gonadal biopsies from both gonads, measuring 1 from the right gonad and 1.4 centimeters from the left gonad, and the operative material was subsequently received. The gonads were also bisected, and upon dissection, both gonads had similar whitish-colored cut surface with numerous foci of calcification. Both gonads were also completely sampled and embedded, while biopsy fragments for parietal peritoneum and greater omentum, as well as 21 regional pelvic lymph nodes, were also received. You can see here the gross appearance of the right gonad, which was bisected, and the left one more having appearance of the streaked gonad. In case 3, the right gonad was also larger and received in 4 fragments, and upon dissection, both gonads had similar variegated appearance, also with multiple areas of microcalcifications. In this case, also, the gonads were completely sampled and embedded. This is the right gonad and the fallopian tube, and the left gonad having the appearance of a streaked gonad. By histology, in case 1, a gonadoblastoma measuring 3 centimeters in diameter was confirmed in the right gonad, while only a microscopic focus of recognizable gonadoblastoma, which was less than 1 millimeter in diameter, was found in the left gonad. The tumors were composed of mixed cells, larger primordial germ cells intimately admixed with smaller sex cord elements, which surrounded round spaces filled with eosinophilic basement-like membrane material. As you can appreciate from these figures from the right gonad, there were many nests of gonadoblastoma in the fibrostroma, variably sized, with foci of calcification at low magnification. At higher magnification, you can find fields with more calcification, replacing the gonadoblastoma nests, and higher magnification of the gonadoblastoma nests. You can appreciate the cellular characteristic of the cells. The larger cells are germ cells, and the smaller fusiform ones are sex cord elements. In the left gonad, only a small focus measuring less than 1 millimeter was detected with areas of calcification, and these are higher magnification where you can appreciate the morphology of the cells. The additional findings were infantile fallopian tubes, while the uninvolved gonadal tissue was composed largely of ovarian-like stroma with extended calcification and having small inclusions, germinal inclusion cysts bilaterally, while only a small focus of Leydig cells were present in the ligamentary tissue on the right. By immunohistochemistry, the neoplastic germ cells were conferred by their nuclear staining for OCT3/4, as well as cytoplasmic positivity for placental alkaline phosphatase and membranous staining for c-KIT, while the Ki67 staining was used to determine the proliferation index, which was low, between 15 and 20%. On the other hand, the sex cord elements were highlighted by positivity for inhibin alpha, calretinin, melan A, as well as WT1 protein. So the diagnosis was of bilateral gonadoblastoma in streaked gonads, figure stage 1C1, in a setting of a Swyer syndrome. In case 2, the histological evaluation of both biopsy fragments and gonads confirmed the presence of bilateral gonadoblastoma, which focally had a morphology of burnt-out gonadoblastoma with many foci of microcalcification, and in addition, in the right gonad, there was a coexisting, moderately differentiated germinoma or dysgerminoma, measuring approximately 1.5 centimeters. It was composed of anastomosing nests of monotonous tumor cells separated by fibrosepta-containing lymphocytes. This is the histology of the right gonad, where you can appreciate at the periphery many gonadoblastoma nests that are calcified, as well as preserved gonadoblastoma nests merging with this germinoma on the left. And here, the dysgerminoma is on the right, where you can appreciate the gonadoblastoma nests on the left. This is a higher magnification showing the morphology of gonadoblastoma nests and the high-power view of the dysgerminoma with characteristic morphology and fibrosepta which are infiltrated by lymphocytes. In the left gonad, only gonadoblastoma nests were present with foci of calcification, as you may appreciate from this high-power view. Additional findings were infantile fallopian tubes, while the uninvolved gonadal tissue, in this case, also had ovarian-type stroma with extended calcification, and only a small focus of Leydig cells were present in the ligamentary tissue on the right, and no tumor tissue was present in the biopsy fragments of parietal, peritoneum, and great omentum, as well as 21 dissected pelvic lymph nodes examined. By immunohistochemistry, both the tumor cells of the dysgerminoma on the left and the germ cells in gonadoblastoma nests were positive for CD3/4, as well as placental alkaline phosphatase and c-KIT, while the proliferation index determined by Ki67 was slightly elevated, 25 to 30%. On the other hand, the sex score elements were highlighted only in gonadoblastoma nests by alpha-inhibin, calretinin, melan A, as well as WT1. So our final diagnosis was of bilateral gonadoblastoma with overgrowth by dysgerminoma in the right gonad, FIGO stage 1C1, in the context of a Swire syndrome. In case 3, the histological evaluation of both gonads confirmed the presence of bilateral focally burnt-out gonadoblastoma, especially in the left gonad, and in addition, in the right gonad, there was a coexisting dysgerminoma measuring approximately 3.8 centimeters. It was well to moderately differentiated, and as a difference from the previous case, there were focally hyalinized septa containing not only lymphocytes, but rare granulomas. As you can appreciate from these figures, this is a low-power view of the right gonad, where you can appreciate the gonadoblastoma nests here merging with dysgerminoma on the bottom. This is the high-power view of gonadoblastoma nests and high-power view of the dysgerminoma, having characteristic appearance with fibroseptum containing many lymphocytes, as well as focally found granulomas. In the left gonad, only gonadoblastoma nests were present, and most of them were calcified. This is the high-power view. Additional findings were infantile fallopian tubes with mesonephric remnants, while the uninvolved gonadal tissue had ovarian-type stroma with extended calcification, and foci of Leydig cells were present in both ligamentary tissues bilaterally. By immunohistochemistry, immunohistochemistry, both these germinoma cells and germ cells from gonadoblastoma were positive for OCT3/4, for placental alkaline phosphatase, c-KIT, and the proliferation index was similarly to the second case between 25 and 30%. Similarly, the sex cord elements in the gonadoblastoma nest were positive for alpha-inhibin, calretinin, melan A, and Wilms tumor 1 protein. Therefore, the final diagnosis in this case was also bilateral gonadoblastoma with overgrowth by dysgerminoma in the right gonad figo stage 1C1 in the setting of a Swyer syndrome. A cytogenetic analysis was done for case 1 and mutation in SRY gene was detected in DNA samples isolated from leukocytes and both gonads of the patient, and the same mutation was also present in patient's father, who is phenotypically a normal male. These are the results of the cytogenetic analysis. I will now go in detail. I will just inform you that this new familial mutation in SRY gene was published in Clinical Genetics in 2007, and the leading author was Professor Blaszewska, present here. The patients with dysgerminoma, case 2 and 3, underwent postoperative chemotherapy, and we are happy that all 3 patients are alive and well without any evidence of disease at 16, 14, and more than 10 years following surgery. Now we proceed with the discussion, and I will start with the definition of ovarian dysgenesis by the 5th edition of WHO classification of tumors of the female genital tumors, where these cancer syndromes are had a separate chapter now, and according to this edition, ovarian or gonadodysgenesis includes congenital disorders of sex development with increased risk of developing gonadoblastoma and other germ cell tumors, which may affect approximately 1 in 4,500 to 5,500 individuals. Gonadodysgenesis is classified in 4 subtypes: 46XY, complete gonadodysgenesis or Swyer syndrome, 46XX, complete gonadodysgenesis, 45X, complete gonadodysgenesis, where Turner syndrome and variants are included, and partial or mixed gonadodysgenesis. The incidence of Swyer syndrome is lower, 1 in 80,000 to 1 in 100,000 cases, and individuals with this syndrome usually present, as in our cases, with primary amenorrhea and absence of secondary sexual characteristics, while in individuals with partial gonadodysgenesis usually present with ambiguous genitalia at birth, and the degree of genital ambiguity ranges widely for an almost female phenotype at one extreme to almost male phenotype with isolated hypospadias at the other. The etiology is different. In Swyer syndrome, most cases are sporadic, while mutation or deletions of SRY gene account for 10 to 20% of the cases, and alterations have also been reported in many other genes, such as SOX9, WT1, DHH, GATA4, etc. As we already heard, some SRY mutations have been found segregating in families, such as in our case, and the mutations were shared between the father and one or more of his children. In 46XX, complete gonadodysgenesis, on the other hand, inactivating mutation of follicular-stimulating receptors have been described, while in 45X, complete gonadodysgenesis, there is partial or complete loss of X chromosome. But in general, the cause and pathogenesis of this gonadodysgenesis at molecular level remain largely unknown. What is hypothesized is that for a variety of reasons, known and unknown, primordial germ cells do not form or interact with gonadal ridge and undergo accelerated atresia, leading to extremely hypoplastic and dysfunctioning gonads that are mainly composed of fibrous tissue, hence the name strict gonads, as we had in our cases. Gonadal dysfunction leads to deficiency of both Müllerian inhibiting factor and testosterone. What is known now is that gonadoblastoma candidate genes are dead box helicase 3, Y-linked, and testis-specific protein Y-linked 1, which were postulated to be present on the proximal part of the short and long arms of the Y chromosome. And the gonadodysgenesis being positive for these two genes are at the highest tumor risk for gonadoblastoma and germinoma. The macroscopic appearance of complete gonadodysgenesis is characteristic for rudimentary or invisible gonadal tissue in both ovarian foci, while on histology, bilateral strict gonads are almost exclusively composed of ovarian-type stroma and rarely contain sex cord-like structures, as you may appreciate from this illustration. On the other hand, in partial gonadodysgenesis, there is a normally developed testis covered with tunica bugynia on one side and a rudimentary or maldeveloped gonadal tissue on the other side, and this is the histology of one of these strict gonads. The patients with complete gonadodysgenesis are raised as females since there is no sexual ambiguity at birth. However, gender assignment for patients with partial gonadodysgenesis is variable and depends on the degree of virilization. Approximately 20% of the patients with gonadodysgenesis develop a gonadal neoplasm within the first 2 decades of life, usually gonadoblastoma, and almost all cases of this tumor have been reported in patients having complete or partial gonadodysgenesis or male pseudohermaphroditism. Other neoplasms include seminomatous germ cell tumors such as seminoma or dysgerminoma, non-seminomatous germ cell tumors such as embryonal carcinoma and choriocarcinoma, as well as non-germ cell tumors such as Film's tumor. Patients with Swyer syndrome are at high risk of developing gonadal neoplasm with the incidence ranging from 38 to 45%. On the other hand, when we are discussing the gonadoblastoma, by definition, in the fifth edition of the WHO classification of tumors, it is a distinctive form of in situ germ cell neoplasia consisting of germ cells, at least some of which are similar to those of germ cell neoplasia in situ of the testis, arranged in nests with incompletely differentiated sex cord cells. It is rare and restricted to patients with gonadal maldevelopment caused by anomalies in genes involved in gonadal embryogenesis. Such so-called degenetic gonads lead to gonadoblastoma in as many as 50 to 60% of the patients. What is known about the etiology? Patients with germline or acquired mutation in the genes WT1 and SRY, such as in Swyer syndrome, develop degenetic gonads and gonadoblastoma, but also required is gonadoblastoma Y region on the Y chromosome, included the candidate TSP Y1 gene in gonadal tissue. In addition, approximately 25 to 35% of the patients with Turner syndrome having Y chromosomal material develop gonadoblastoma, as do about 5% of patients with androgen insensitivity syndrome. However, there have been rare cases of gonadoblastoma reported with normal karyotype. The pathogenesis is also hypothesized, and here we know that most patients are phenotypically female, but the involved gonads carry Y chromosome genes, and they are identifiable as testis in 20%, as strix in 20%, but none of the gonads are recognizable ovaries. Because of mutations in the pathway of testicular development and absence of functional androgen, SOX9 expression is inadequate to support a normal seminiferous tubules and sertoli cells with VOXL2 predominating. As a consequence, germ cells have delayed maturation with co-expression of OCT3/4 and TSPY, which with enhanced KIT-KIT ligand signaling are believed to promote their neoplastic transformation. Therefore, it is hypothesized that the TSPY1 gene acts as an oncogene in germ cell lacking adjacent functioning Sertoli cells. It is also worth mentioning that activating KIT mutations are found in more than a half of dysgerminomas in patients without gonadal-dygenesis, but only in 6% of dysgerminomas in patients with gonadal-dygenesis. Patients' age ranges from neonatal to 4 decades of life, and about half of the patients appear as virilized females, 30% as non-virilized females, and 20% as males with hypospadias and cryptorchidism. Most cases are found during investigation for possible disordered sex development, and some cases, as in our presented here, present later, typically with primary amenorrhea. Macroscopically, most gonadoblastomas are ill-defined 10-degree areas with gritty texture and with progression to invasive germ cell tumor features specific to that entity are seen. You can appreciate here a strict gonad with gonadoblastoma. This is the fallopian tube. Histologically, it is a typical appearance, which I have already presented. Multiple nests separated by fibrous stroma composed of 3 elements: larger germ cells, smaller fusiform sex cord elements, and rounded spaces filled with eosinophilic basement membrane-like material with foci of calcification. Occasional cases show large anastomosing nests resembling germinoma, while testes or strict gonad may be found at the periphery. In 2/3 of the cases, the surrounding areas have a corded pattern of the same component cells, which have been termed both dissecting gonadoblastoma or undifferentiated gonadal tissue, which is illustrated here, and alpha inhibin is used to highlight the sex cord elements in these nests. According to the findings of the single largest study by Scully from 1970, in about half of the cases with gonadoblastoma, an invasive germinoma was present, and in another 10%, another malignant germ cell neoplasm, such as Yolk sac tumor or immature teratoma or embryonal carcinoma or choriocarcinoma were diagnosed. Rarely, sex cord component undergoes malignant transformation. By immunohistochemical staining, the germ cells are positive for markers characteristic for germinoma, such as OCT3/4, podoplanin, placental alkyl phosphatase, c-KIT, SAL4, and D240, while OCT3/4 is a reliable marker for type 2 germ cell tumors with pluripotent potential. On the other hand, the sex cord cells stain positive for inhibin, calretinin, SF1, WT1, CD56, as well as granulosa cell marker FOXL2, and are almost always negative or only weakly positive for Sertoli cell marker SOX9. This reflects a blockage in testicular differentiation. These are the illustration for the positivity of the germ cells for SAL4, as well as OCT3/4, c-KIT, and D240, and positivity for sex cord elements for alpha inhibin. The differential diagnosis includes sex cord tumor with annular tubules, but here the patient has a normal karyotype, normal background gonad is found, and germ cells are absent in the nests. On the other hand, the other differential diagnosis is mixed germ cell sex cord stromal tumor unclassified, found in patients also with normal karyotype, normal background gonad. Typically, the tumor is unilateral and lacks distinctive nested architecture for gonadoblastoma. The next differential diagnosis is germinoma, but in this case, sex cord-like cells are absent in the nest. And the last last differential diagnosis is Sertoli cell nodule populated with germ cell neoplasia in situ. In this case, patients lack clinical features of gonadodygenesis, and by immunohistochemistry, there is a strong SOX9 and absent FOXL2 reactivity in sex cord cells. So these are my take-home messages for you concerning the Swyer syndrome. You can expect bilateral streak gonads, and what is important for clinicians also, that these patients appear to have a high risk of developing tumors in their dysgenetic gonads. The tumor transformation in the gonadal ridge can occur at any age. And the most common tumor is often bilateral gonadoblastoma as a precursor lesion, but dysgerminoma and even embryonal carcinoma are also seen. This is why a prophylactic or therapeutic gonadectomy is often indicated when Swyer syndrome is diagnosed. For the clinician, it is also important to know that estrogen and progestin sequential therapy supports female secondary sex development in these patients and they are potential candidate for donor oocyte. For gonadoblastoma, it typically arises in a background of dysgenetic gonad. Classical morphology is of nested architecture with hyaline basement membrane-like material and calcification. It is composed of germ cells positive for SALL4 and OCD3/4, and sex cord stromal cells positive for inhibin and SF1. It can progress, therefore, early prophylactic removal of the gonads in this patient is advised, especially if you have a presence of undifferentiated gonadal tissue or testicular tissue with OCD3/4 positive cells on the basal lamina confirmed by gonadal biopsy. It is also important to exclude the presence of dysgerminoma or other malignant germ cell tumors by rigorous sampling, particularly if you have a large-site gonadoblastoma. Thank you for your attention.
So thank you very much, Professor, and thank you for promoting the awareness about gynecological cancer, because as you show, both common and even whereas the rare gynecological cancer, of course, I mean, we need collaboration and we need to continue increasing the awareness on that. And you are at the forefront, you're a frontliner in that. So are there any questions for Professor? And by any chance, I mean, I know that you've published extensively and together with colleagues. Do you intend, I mean, because this is really interesting, I mean, maybe doing it as part of a case series or a review article on this important topic?
Yes, we will consider that, but we were lacking information about the other two patients. We tried to, because it was obvious that the biopsy were taken during the operation, but we were lacking the further information about cytogenetic analysis, and that stopped us from proceeding. Yes, from proceeding.
But as you know, there is the support of Gynocare Skopje, which is always ready to help with support and publications. I mean, in the audience, we also have experts who are, they lead journals. So, we're always open for collaboration.
Yes,
thank you so much for this very, very interesting talk. And now, for the last lecture before the lunch break, it's my great pleasure to introduce Professor Neville Calleja, who I happen to know very well. And he is the Director of Health Information and Research at the Ministry of Health in Malta. He's also the Head of Department of Public Health at the University of Malta. And he's going to talk to us about setting up a register for rare cancers, including rare gynae cancers.
Okay, so welcome everyone. Just trying to see how to share this.
It's either never done.
Okay, great. Okay, so as Jean explained, so I've been involved in health information for couple of decades now, not just in Malta, but also at both EU and WHO level. And part of my work, actually, especially with WHO, involves assessing health information systems in different countries in Europe. And I think to date there have been, well, quite a few. I think we had some training in Macedonia a few years back on this. If I recollect, maybe it was 2016 or 2017. And many other countries in the Balkans have also done such assessments. Typically during these assessments, what comes up is the difficulty to maintain epidemiological or clinical registers because of the effort that is required, because maybe the clinicians are not complying or not helping, not sending the data, not sharing the data, okay, for a variety of reasons. So I believe in the eastern part of Europe, there is less issue of territoriality with clinicians, which we tend to find more in the West. In the West of Europe, we tend to find clinicians tending to try and keep information to themselves. I think in the East there is a bit more of a tradition of statistics collection, etc., which possibly dates back also to Soviet times. Nonetheless, there are other difficulties. So what I'd like to discuss with you over the next few minutes, I'm also aware of being very tightly sandwiched between you and lunch, so I'll try not to exceed my time. But I'd like to discuss with you also maybe a lighter presentation at the end of this really rich morning as to tips of the trade, so to say, how to try and ensure if you're setting up a new register of anything, can be rare diseases, cancers, whatever you wish, how you can try to ensure its sustainability and that it doesn't burden you so much to maintain it. So first of all, you need to know what you want to achieve. Okay? Why are you doing this register? What's the objective behind it? All right, so if you're trying to monitor events, if you're trying to characterize your population or certain diseases, which groups of the population are being affected, okay, so understanding these differences, identifying vulnerable groups. You might also be monitoring models that have been hypothesized already, monitoring the consequences of certain characteristics. I've been discussing with a Turkish colleague during the coffee break about some brilliant work we've seen in Israel, where health records have been analyzed like 7 years back in time in order to identify who was at risk of developing certain complications 7 years down the line. And this was done by an insurance company, and they managed to actually flatten the growth they were observing in the demand for hemodialysis by targeting these individuals, which was amazing work. I think actually they've evolved into other pathologies now. And the impact of specific interventions as well, why not? Okay, be it prevention initiatives, be it treatment initiatives. We've had clinical trials, for example, on things like osteoporosis, where to monitor treatment, it takes ages, okay? HRT, same. I mean, if you want to monitor mortality post-HRT, it's not within the lifetime of a typical clinical trial. So it might be worth having a register or latching up with a register and following up these patients 15 years down the line, which we have done in Malta in the past. You want to know who your users are going to be. Ideally, you want to keep your options open, because if you have a register, you want it to be used. Okay, a register which you keep to yourself, frankly, might as well not even start. Okay, so a register is there to keep data to be used. So think of researchers, think of policymakers, clinicians who might wish to carry out research using your data, why not? Audits of services, and, well, whatever you can think of. Okay? Which population shall be included in your register? All right, it might be based on a single hospital, national, regional, public or private, or both. well-defined geographical area, ideally you might wish to make sure that you have your geographical area well-defined. Why? Because if you want to generate certain indicators like prevalence and incidence, you want to know what your population is. If you don't know what your population is, it's a bit difficult to do that. Okay? You might wish to make sure that there are vital statistics that are routinely collected about this population that you're monitoring, so that you can do this sort of thing. Okay? And another thing, it's important to try and maximize completeness and representativeness of the data that you are collecting. If you're not able, and please, this is important, I'm not sure how many of you have heard of the Pareto principle, okay? To go from, so typically, to collect the last 20% of your data takes 80% of your resources, okay? So sometimes trying to go for 100%, and we as clinicians are, always terrible at this. We always want everything. We always want perfection. To achieve that last 20% coverage, representativeness, accuracy can cost you so much more than actually the other 80%, which is more readily available. And frankly, sometimes that at 80% gives you enough information to at least show you where things are going. And then maybe you can invest more time in getting more detail. We sometimes do, I'm seeing Rita in the audience here, she's the lead, and she has been the lead on our cancer registry in Malta, which is hugely respected and highly involved in cancer research projects around Europe. And I think Rita herself has been involved as well in some high-resolution studies. That sometimes there's a pathology of interest at European level, and we might go back to those patients, to those clinical records, and get more detailed information. Now, think about your data sources. So one most important thing to ensure sustainability of your register is to have a sustainable data source. Okay? So if you're going to go to your clinicians every time and ask them to fill in an extra form, consider yourself out of business within max 5 years, if you last 5 years. Okay? So make sure to keep this in place, the burden on the clinical staff. I've been in a country doing a health information system last year. I will not identify it. But they had so many registers and all were mandated by law that every hospital, this you might not believe me, but we saw it and it was consistent, 25% of their staff were actually data inputters for clinical registries that were mandated by law. Because over the last couple of decades, these registers have grown and grown and grown, and they have to enter the same information 10, 15 times. Okay? That is not sustainable. Ideally, the data capture is electronic. Okay? Again, looking at Rita, we're in a process of moving now from paper-based results, and our cancer registry is a very active register. I'll come to that in terms of active versus passive. Monitoring results on paper, involves a lot of logistical difficulty. Okay? Ideally, you have electronic systems that feed in your direction the data that needs to be captured. And even better if that electronic data is somehow included in a data warehouse. What's a data warehouse as opposed to a data set? It's basically a number of data sets that are linked in some way or another, usually in your e-health infrastructure or e-health records, okay? Many of our countries have identity card numbers. That presents a major opportunity for data warehousing, okay? Case in point, quick example, when we needed to do a diabetes strategy, we didn't have a diabetes register, okay? But we needed to get information around our diabetics, where are they going well, where are they going badly. We basically use the ID card number to link several data sources, okay, treatment database, surgical database, outpatient databases, whatever was required. We just linked them together and we created what I call a register on the fly. Okay, we actually need to do it again. I've just received an email as I was listening this morning because the diabetes strategy is reaching its sunset. So this actually becomes possible as well when you have data in a data warehouse. It might not be a sexy infrastructure, but at least you have data sets that can be linked. I mean, I must admit, hand on heart, that most of the linkage we do is done even in Excel, sometimes in Microsoft Excel. Okay. Now, if you want to keep data in a register, if you want to make it usable by as many stakeholders as possible, you need to classify it. Okay. Free text data is not very usable. Okay. So structured data is required. There are multiple ways medical concepts can be expressed. We'll be discussing a few of these classification systems, and I'm not sure if you feel it here in Macedonia. Definitely in the EU it's being felt strongly. There is increasing demand for what we call secondary data use. I'm not sure how many of you are familiar with this, but the EU is planning over the next 2 years to go for what they call the European health data space, where basically health records become interoperable within country and between countries. Okay? Not just for the delivery of healthcare across borders, but actually also for secondary use of data. Okay, so why use a classification system? As we discussed, it allows easy storage, but even better, it allows quick retrieval and analysis. Okay, being standardized, they allow us to compare between hospitals, between regions, between countries. Okay, and also across time. People change over time. Okay, so if you don't have standard classification, as your coders are changing, you might actually lose that continuity. Okay, I'll just skip this as is obvious. So a good coding system, there are various out there, and you will probably have to face the decision, which coding system am I going to use? Okay, should be as objective as possible. All right, so not subjective. What do I mean by subjective? Again, quick story. One of the most subjective diagnoses to have to do in mortality coding is diabetes, because it's so complex, so multifactorial. And if you look at, I think, the little secret, if you look at the trend in mortality by diabetes for Malta, you can spot where our mortality coder had her baby. Because I had to change coder for a couple of years while she was in maternity leave, and it's a bit subjective, you see, how to code diabetes. He was obviously coding slightly differently, so we have a break in series until she came back from maternity. So these things can easily happen with a standardized classification system, let alone if you didn't have a standardized classification system. Discrete, in what sense? For example, ICD-10 has quite a big problem with rare diseases and syndromes, because you end up finding a bit of the syndrome in one chapter and another bit in another chapter, so it's not discrete enough for rare diseases. So this is why then one hopes that ICD-11, which has just been launched, will hopefully address this gap. And I think there's another, in reality, there is another classification system for rare diseases. Some of you might be familiar with that, known as ORFA, the ORFA codes. Okay? It should include as much information which is relevant and exclude all that is not relevant. Tough question. What is relevant? What is not relevant? You'll have to use your experience and feedback from your users as well, okay? Especially as you start developing your register. Don't expect to have it perfect immediately as soon as you start the register. The register might have to evolve and add fields or drop fields possibly. Okay? This, to some extent, we discussed, so you need to make sure you have the right classification system for the job. Some examples quickly. ICD-10 is something I think that many of you are familiar with. In many countries, clinicians actually code ICD-10 at the point of contact. In other countries, coding happens later. In my country, for example, coding happens centrally after care is being delivered, because we can do it, because we are small and we are centralized, and frankly, we achieve more consistency like that. Okay, but it's not always the case. ICPC is a classification that is usually used in a primary care setting and sometimes in an emergency care setting because it's about presenting complaints. ISCO 08, now this is not a medical classification system, but we need these kind of systems as well. ISCO 08 is a classification of occupations, all right? So if you want to look at, even for our young attendees, if you're carrying out, your own research and you want to capture occupation, how can I work with occupation in my survey? Best to code your occupations using ISCO 08. Most of these are freely available, by the way, okay? So most of these don't even cost a penny to use. NACE, which is a classification of employments, all right, banking, agriculture, forestry, whatever. ISCED, Education 11, many others. Quick word on something called SNOMED, because SNOMED is taking classification systems by storm because it is very well designed for electronic systems. So SNOMED, in a nutshell, is not a classification system, but we call it a natural language processing system. What does it mean? It can actually pick up terms from our clinical records and based on those terms highlight which classification systems apply. So, that little blurb that the doctor is writing after an encounter in hospital or in a healthcare setting, that can be linked or mined, if you wish, into various classification systems. So SNOMED is a very good system at the heart of several new record systems that are being developed. Okay. Quick run through. I think we discussed a few of these. I'm conscious of time. So ICD-10, ICD has a very long history. We started using it in the 1990s, ICD-10 itself actually, but ICD itself has quite a long history. ICPC we discussed. This is quite convenient for the small practice. Okay, general practitioner, for example, still doesn't know what the diagnosis is, so it's best to classify around presenting complaint. It literally fits on 2 A4 sheets, the whole classification system, so it's quite nice to use in a small setting. ISCO 08 we discussed, 08 because it was revised in 2010 date. If you have access to the older one, the 88 is very weak, it's very weak on IT, for example, which obviously was different in 1988. NACE 2, it's used across the board by all national statistics offices, I'm sure, including here in Macedonia. And again, it's easily accessible freely. It's defined also by European legislation because there's a lot that depends on it, as you can imagine. ISCED is a standard educational classification, very detailed, I must admit, but it allows you to compare to other countries. In most cases, in fact, for local consumption, when we're doing analysis for ourselves, we collapse the categories into more manageable ones that correspond to our national educational system. But this was designed, remember, to be able to compare countries. So some of you might be familiar with this, ATC, which applies to pharmaceutical products. Okay, ICD-11 is the new version of ICD-10, intended to facilitate its use in electronic systems. It's been recently deployed. It was planned for 2015. It was delayed by several things, COVID included. But in fact, I think WHO now will actually start requiring data to be sent according to ICD-11 codes as of 2022. Now, How are we going to identify the events of interest for our register? Okay. Really, there are various ways of doing it. It can be manual. I think if you have an opportunity to discuss these with Rita, she has even more experience than myself on this. Manual obviously is very labor intensive. It can also be deterministic or probabilistic, so through data linkage, all right? Again, that ID number that many of our countries have can be very useful. You might start bringing up questions here on data privacy. Remember that most data privacy legal frameworks have provisos for the collection of statistics and the protection of public health and the management of healthcare services. These are three widely accepted exceptions that allow us to process personal data, allows, well, not everyone, designated agents to process personal data for these specific purposes. If you have a look at GDPR, for those of you who are coming from EU countries, I know that several other countries, even here in the Balkans, tend to follow GDPR quite a lot, even in their domestic legislation. You will find an entire chapter dedicated to secondary processing of personal health data, and this is definitely included. Okay, so that's something you might wish to think of. Hot and cold pursuit, I did mention this, that I intended to get to this. A mortality register is cold pursuit. Why? Because the certificate comes to the mortality register, is coded and entered. Okay? In my country, we have a lukewarm pursuit, if you wish, because apart from the certificate coming in, if there is a doubt, we have access to the medical record of the deceased person and we can verify certain issues. Cancer registration is a blast furnace, if you wish. It's very hot because it involves trawling through a lot of pathology, radiology records, and also cancer notification forms. Many of you come from countries where there is cancer notification as a legal requirement on clinicians, but frankly, it's very difficult to enforce. And I think most cancer registration these days relies a lot on data from labs and radiology. Quality control is important. As we said, you want to make sure that your cases are complete and the cases you're receiving information about, the information is complete, okay? So you basically, like this, you can actually take into account any bias from diagnostic practices, for example. Certain people might not do certain things or not give you certain data. New tools. Sometimes it's amazing what creates an earthquake in your data. So I remember when we had a new pathologist joining the local hospital. We have one big hospital, and she was an expert in thyroid cancer, and she was detecting thyroid cancers that before were not being detected. And lo and behold, we had an explosion of thyroid cancer over a span of a year or two. So, you need to be able to pick up these things. You need to ensure that there is data comparability within the register, across time and across populations, and also between countries, okay? Which is also one other reason why we use classification systems. You also wish to ensure internal validity, okay? So, is the data you're capturing good? I'm going to veer off the cancer registry now. The obstetric registry. If you try to assess how big a problem is drug abuse in our obstetric register, you get a fairly good picture, because let's be fair, if you have a drug-dependent mother, it's typically difficult to hide. But if you ask them about smoking, or even worse, alcohol, like, are you drinking any alcohol? No. Okay, desirability bias. So we know that we really can't rely on certain variables in certain registers, or at least we know how to correct them. Okay, external validity. You want to make sure that the rate of events you're getting through your register matches that from other sources, like your National Statistics Office, and that concordance gives you comfort. You know, I'm on the right track. Okay, I might be capturing 80% of the data, but I'm on the right track. Okay, I'm still representative. We're soon done, I won't keep you too long. Typically, one comes to the question, which IT solution? Okay? Really, it's up to you. It's up to your resources. What I would recommend is to keep it as simple and as versatile as possible, because ultimately, you want your data to be usable. I've seen so many systems over the years that have been custom-made to collect data, and then if you actually need to query the data, you have to go back to the programmers to extract it for you. What's the point? Okay? If you have resources available to invest in your IT solution, try to get that automatic data linkage, okay? And maybe feeding streams into your system from clinical records, okay? Try to get reports being issued regularly from your system, as opposed to having to report the same tables year after year. Okay, if you know the tables that you require year after year, why not program them into the system? Okay, and this last point, I think I need to put it in with a little parenthesis. So, for most of us starting off, I would recommend to avoid storage on the cloud. Okay, so you don't want to put your data set in your G drive, in your OneDrive, okay? Because ultimately, you know, you might say, oh, it's so secure, it's so secure. Well, that's what we used to say with many places, with many data sources 20 years back, which are now easily hackable. So we need to be careful with this. All right, that said, nowadays we're seeing very strong cloud services. Many of them provided by the major commercial companies. Even for those of you coming from the EU, these companies are actually offering cloud services that are hosted in the EU. Okay, so in fact nowadays our systems back home are actually hosted on Microsoft Azure, frankly. And over COVID, actually, when health information moved from being something that you don't really think about, like the people who collect your garbage sort of thing, sorry, I don't want to be disrespectful, but that's a fact, we came into the limelight. And we had a lot of hacking attempts in many countries. We've seen this. Ireland had one big crisis, in fact. And funnily enough, what survived better were those data sources that were hosted in these secure cloud services, not those that were hosted in the networks within the institution about which people were feeling rather safe, and it wasn't. Okay, last slide, and off to lunch. Just a quick summary. So first and foremost, get a good grasp of the demand, why you want to start collecting this data. Make sure you know about whom and which data you will be needing in terms of routine data, like population figures, etc. I would carry out a pilot study before starting off. You don't want to invest a lot of money and then find things that you didn't know about, okay? So it's always good to do a bit of a pilot study before going large. Record linkage is always something that you want to keep at the back of your mind, because the more record linkage you have, the more sustainable the system becomes, because the less input you need from the clinicians, you know, the less extra time you need from the clinician's side. I think some of the registries that survived best and quite easily back home were those linked to systems where, as a principle, and I think Rita can confirm, we try not to actually give any forms to doctors. We just extract from systems across all 10 registers that we have, okay? And this has helped our registries survive 20, 35 years to date. Once you're done, ideally, you can set up your population-based register. And important, step 5, don't just sit on it, analyze it, and disseminate it. And if you don't have the capacity, like we do, we're a very small department, open up. Let the academics come along and analyze your data as well. Okay, so that's it from myself. Hope it was useful.
So thank you very much. Any questions at all? I think it was very clear. So thank you.
Thank you.
And now, before breaking off for lunch, if we could have you for literally a few minutes in order to take a photo, you know, because I'm aware it's the last day and some of you need to travel today. So if we could have a photo, so Prof. Grigor will tell us where best to meet, or Yasmin actually, yes? Okay, and have a poster, yes. Okay, so for the rest of you following us on Zoom, we'll be back at 2 o'clock, okay? Thank you.